many years to realize that it wouldn't have come out of that primordial soup. Yet the statements are made, right? Well, let's go on. So they have never made them. They've never made proteins randomly. They've never made any of this stuff randomly. The answer is no. Why can't they do it? Or even a DNA or an RNA or a protein by random? Because these chemicals will have unique qualities to them. They have unique components. The key thing is that they contain information. Now, since they're not living and they have no control over what they do, per se, that information had to come from somewhere else. It couldn't have come from the chemical components themselves. It's impossible. They have no control over that. Information had to be imparted into these chemical components, right? And they have lots of information in biological systems, okay? DNA is like a bunch of chemical sentences strung together, such as to read out the word an arm, or a leg, or an eye, or a brain, or whatever the particular components of the DNA are going to generate in the cellular structure to form those components in the entity in which it exists. Can sentences be made by chance? Let's look at it. Okay. Oh, I'm sorry, going backwards. Well, let's do a little experiment. We're going to see if sentences can be made by chance. Okay. Let's take 3 D's, 2 E's, 1 G, 1 H, 2 L's, 4 O's, 1 R, 1 S, 1 T, and 1 W. Now that's only 17 letters. That's not a whole lot of components to deal with to make a sentence by chance. I mean, gee whiz, when we're dealing with cells and the molecules that are necessary for cells, we're dealing with a much, much greater variety of possibilities there, right? Much, much greater. So this is a fairly small test. This is not a big test. Okay. We're going to put it in the box and we're going to pull out 1 letter at a time. All right? We get these letters. LD, LGD, SLEO, and so on and so forth. And that's the kind of letters we get out. Now, there's no language, no English language that has a word that's spelt like that. So then what would you say about that order of those letters? You would say what? You'd say it's meaningless. It has no information, right? It has absolutely no information. So we go a little bit further. Let's suppose you are fortunate enough and you're going to do a little better job and they're not going to be so scrambled as this. But now you're going to come up with this situation. You got all the D's together, you got the E's together, the G and the H, the 2 L's, the O's, the R, S, T, W. That's a little bit better because now you got some organization, right? Yeah, you got some organization. But do you have any information? No. That does not spell a word. That does not identify with a word in anybody's language. So again, we got some organization, but what? No information. See? Okay, let's go another step further. Order alphabet arrangement, not much else. That's about all you got, right? Randomness produces scrambled arrangements of letters, or some order, but has no meaning, has no information. No meaning means no information, okay? So what? You know what the letters really said? There it is. God so loved the world. That's what they really say. Now that's information. That's order. Okay? And that's the difference. All right? So we know that randomness cannot lead to order. I don't care what mathematician you talk to about theories of randomness and probability. I don't care what experts say they've done what experiments. They cannot prove that order comes out of randomness. There is no way to demonstrate that. The physicists are talking all the time about the disorder and the chaos of the Big Bang and how all the components came together and to be ordered. That's strictly conjecture. That's strictly hypothesis. and they have no substance to that at all. Order cannot come out of randomness. Okay, so this is a chance, one chance in 100 trillion experiments that you could have gotten that word, by the way. So that's how unlikely it is you would have unscrambled those letters to get that information. So it cannot produce any sentences. It cannot make chemical sentences either. And it cannot make DNA, and it cannot make DNA do what it has to do, or the DNA library as we call it. Fred Hoyle, one of the scientists of recent times. Fred Hoyle is in Nature, made some pretty bold statements. He was a well-known British mathematician, astronomer, and originator of the steady-state theory of the Big Bang, actually, and the origin of the universe. Fred Hoyle was a very intelligent man. Fred said he offered statistics on some aspects of the probabilities. The likelihood of the formation of life from inanimate matter is virtually zero. It is big enough to bury Darwin in the whole theory of evolution. That's what Hoyle says. Hoyle wasn't a creationist. Interesting, right? Okay. That was quoted from Hoyle on evolution in Nature, a scientific publication. There's the volume, November 12th, 1981. And the chances of it is 1 in the number 10 raised to the 40,000 power. If you can imagine that kind of number. It's so minuscule when you divide 1 by such a number as that, you just as well say it's 0 by any stretch of the imagination. In fact, Ernest Borel, who was Emile Borel, who was a statistician, one of the world's best experts on statistics and probability, years ago put forth some publication which said, if we're looking for the chances of probability, once you get out of the realm of 1 chance in 10 to the 50,